Okay, so these are the harder problems here. These are the tough ones where you are combining quadratic solution methods with trigonometric functions. That's pretty hardcore. So what we're going to do is we're going to see that this guy is sine to the first power. This guy's sine to the second. I don't see any cosines, so it looks like this is going to be in a quadratic form, okay? And we're going to basically treat sine theta as just an x, okay? But anyways, what you want to do, though, is you want to move everything over to the right-hand side here because this guy needs to be set to 0. So we're going to add plus 1 plus 3 sine squared theta. And then we're going to move this over here a little bit. It's moving, okay. Then we're going to add up plus 1, and then the plus 3 sine squared theta. All right. So this guy's all 0. And then what we got is we have 1 plus 2 sine theta plus 1 sine squared theta. All right, move this away. Okay, so back here too. All right, so this guy's a quadratic, and I don't like to see them rearranged. Now, I think what I will do, though, for this problem is I just want us for a second to just say that x, let's try something else here. For those of you that are kind of having a hard time with this, I'm going to just pull out a substitution, okay? I'm going to take sine theta out of the game and replace him with somebody who also can play the position, okay? So I'm going to pull a little substitution here, okay? What I'm going to do is, because x is sine theta and here sine is being squared, I can just say x squared. Okay, sine theta is here, but remember we just said he was x, so now we got 2x. There's plus 1. Okay, so this is what you're doing in this case. Maybe some of you, already can see that, cool, but I just want you to know that this is what we're doing here. Okay, we're going to use the x method to find factors of 1 that add up to 2, and that's 1 and 1. And so what we've got is x plus 1 and then x plus 1. All right. So now we've used the quadratic method, quadratic techniques of solving this. We can actually put the sign back into the game. But notice that what we've got is we've got parentheses that are identical. And so what this means is the same answer that'll give me 0 here is the same answer that'll give me 0 here. All right. So there's no need to write my answer twice. Okay, so what we do is we're just going to go ahead and just have this guy here. Sine theta, plus 1 equals 0. And we're going to move this, the 1 over to the other side. And so now we just want to find what values of theta that are sine that will give us -1. And it looks like this is where sine right here is -1. And so that would be 3 pi over 2. Okay, so 3 pi over 2. So here, just using the quadratic form to solve a trigonometric situation. And so this guy would just produce 3 pi over 2 as well. All right, so my paper had some other stuff written out, so just I'm going to go ahead and just do 22 here. I'm going to recopy it. 2 tangent theta minus 4 equals -3 plus tangent squared theta. Oops. Okay, same process here. All right, we're going to move these guys over to here. I like that it's just a plain old tangent squared theta. And he's positive. And so we're going to move these guys over to there, so he'll be 0. So I'm gonna put this guy in the front too. I'm gonna try to kill 2 birds with 1 stone, reorganize it as we move things over. This 2 tangent theta will move over, but he'll be negative. He will not combine with tangent squared theta. They are what are called unlike terms, right? Quote unquote. And we would say unlike expressions, I guess, because they're tangent is a function. But now we're going to move this guy over here with a plus 4. Adding to that, that'd be a plus 1. Okay, so what I'm going to do is I'm not going to replace the tangent with an x. I'm just going to go ahead and just factor it. Okay, so this would be factors of 2 that 1 that add up to -2. That would be a -1 and a -1. So I've got tangent theta -1 times tangent theta -1. All right, so this, think about foiling, and it would give me that. Okay, so this is fact. They're identical, so it looks like I only have to do this once. There's not 2 equations for me to solve. There's only 1, and no need to write my answers twice. So I'm just looking at this parenthesis here because that's identical. I'm going to move the 1 over to the other side. It'll become positive. And I just have to ask, well, what values of theta produce 1? So I go back to my unit circle here. And tangent is positive in the first and the third quadrant. So he is power 4. All right, and then over here, he is 5 power 4. All right. That one's it. That's it. We'll do, where we at? 6. Okay, we'll do 23. All right, I see a cosine squared, and I see a... Okay, all right. So this one's got a lot of action to it. Excuse me. Okay. All right, so if I... All right, so here's what I see. If I move this guy over here, he will become negative, and that is not actually an identity. If this would have been a negative cosine squared theta, I would have moved over here and got a 1. Then this would have been super straightforward. But that is not what I have. So what I'm going to do then is I'm going to turn this. Now I see this sign here. So if that wasn't there, I would pretty much have a quadratic expression here for sine. Because of the cosine squared, I think what I'm going to do is this. I'm going to go ahead and use the identity that says cosine squared is 1 minus sine squared theta. Now, I am just replacing this outright. It's not being multiplied to anything. So this guy is just a real clean substitution there. All right, just real clean. And so now I'm just going to add and combine like terms here. Looks like this it's 3. Okay, I'm just making sure we can do here. I'm going to move this sine squared over to the other side. In fact, I'm going to move everything over to the other side. So these guys will combine for a -1. So this means that 0 equals, I'm going to get 2 sine squared theta minus 3 sine theta. And then those -1 will become +1. Okay, so looks like we're doing the AC method. The AC method requires me to multiply the front and the back. Now this is just a straight up quadratic form, okay? Something squared, not squared, and constant. So I want 2 times 1, 2, -3. Factors of 2 that'll give me -3 is -2 and -1. Okay, so this means I got 0 minus 2 sine theta minus 1. I'll just write 1 plus 1. Okay, and now we're going to split it down the middle. All right, and this is the grouping part of the AC method. Here I can take out a 2 and a sine, and I will get sine minus 1. Over here, if I took out a negative sign, I would have this, that would become negative as well. So then I got a sine minus 1. That's exactly what I need. So I've got 0 equaling, now this is just quadratics now. This is the AC method. I know it seems like a lot because you got a sine theta going around, but you are doing the exact same thing that you did if it was just an x, okay? The only thing really new here is that identity is something that you can't do with normal quadratics, and what we're about to do right here. We're about to take these guys out, set them equal to 0, and instead of just solving two-step equations, we go to our unit circle to get those answers, okay? So we got two pieces of parentheses that have to be set to 0, so this could possibly give us 4 answers. Okay. All right, so let's go ahead and then move, let's solve this part first. Okay, so we're going to move that guy over. 2 sine theta equals 1 divided by 2. All right. Kind of just feels like, maybe just because I've helped you guys out, I just kind of see that kind of the same patterns fall with this stuff. Let's figure out where sine is a half. E is half at pi over 6. Now, I'm looking at my unit circle now, okay? It's not magic. And then sine is also positive 1/2 right here at 5 pi over 6, okay? All right, so there's 2 answers for this guy. Now let's move over here. Let's move that 1 over there, and then sine theta will just be equal to positive 1, and that happens only at pi over 2, all right? So this means that theta equals pi over 2. So this means that not only do I have these guys, but I also have this guy coming around. Doesn't matter which order, but it'll probably, if you were taking the SAT, this would look like this. It would be pi over 6, then pi over 2, and then 5 pi over 6, because they would basically go around the unit circle. Okay, and I just want to make sure, yep. Okay, so that's it. We'll stop right there for this one. So, pretty impressive problem. All right, pretty impressive.